Hello everyone, my name is Vandit and I'm currently a master's student at ETH Zurich. Today I will be presenting a work on understanding and improving the efficacy of data dashboards for better controlling the privacy of voice assistant collected data. This work was done in collaboration with Professor Mainack Mondal as part of my bachelor's thesis at IIT Kharagpur, India. This talk is about the privacy of voice assistant data. So what are voice assistants? Voice assistants are software agents that can comprehend humans to perform user-defined tasks, such as playing a song or opening an app. Some examples of popular voice assistants include Siri, Google Voice Assistant, Alexa, and Cortana. Among all these voice assistants, Google Voice Assistant or GVA enjoys a special position, as it is included in most Android phones these days, besides also being present in Google Home devices. Today, GVA runs on over 1 billion devices and has an active user base all across the world. This is why we focus on GVA in our work. At the time of our study, GVA could collect the following 6 data types for each interaction, namely audio clips, transcripts, location data, reminders, as well as metadata such as date and time. Whenever you use the voice assistant, all this data is uploaded to Google servers, where it can stay forever unless you decide to change your privacy settings. However, some of this data might be sensitive. Let me present to you some scenarios where a user might feel uncomfortable sharing this data with Google. Imagine if there still existed a recording of yours from the time when you accidentally activated your smartphone voice assistant while trying to call someone during a medical emergency. There existed recordings of your children from the time when they were playing around with the assistant. If the voice assistant somehow knew the location of your last family dinner during the holiday season when you used it to play some songs. If it had your complete flight history. And finally, if it had some funny or even slightly embarrassing recordings of yours from the time when you were playing around with it. These were precisely the kind of data elements we found while browsing through our personal data collected by GVA. Not collecting this data or mass deleting everything might not be an option at all, because users want better recommendations and perhaps more control over their data. Companies, on the other hand, also need user data to improve their services. So how can users control the privacy of this GVA collected potentially sensitive data? Through privacy dashboards. At present, Google offers an online dashboard called the My Activity dashboard, where users can obtain a list view of all their stored prior interactions with the Google Assistant. They can also filter based on the date and specific keywords. Prior work has also shown that users are aware about data collection by voice assistants. However, this approach to privacy management of voice assistant data suffers from two main problems. Firstly, it is hard for users to search for potentially sensitive data based on keywords, as they might not know what exactly to search for. The second issue is that individually going over each collected data element causes a huge cognitive overload, making it practically infeasible for users to effectively manage the privacy of large amounts of collected data. This slide highlights the issue of cognitive overload required to manually inspect a data element. Here, we have a basic smart home interaction with the assistant. In order to check the complete collected data, a user first needs to click on Details, then click on View Recording or View General Area for location, and then play the recording or try to look at the location and estimate the place it corresponds to. This creates a massive cognitive overload for the users, and it is not hard to see how this can cause issue with privacy management of huge amounts of collected data. This brings us to the focus of our work. There has been no real-world data-driven prior study on understanding how people use this data dashboard for controlling the privacy of GVA data. Our goal with this work is to understand the effectiveness of current data dashboards and to investigate automated techniques that can help improve the usability of these dashboards. In the rest of the talk, I will first present an overview of our study, then share some key results, and finally suggest a machine learning-based technique to help users easily find the sensitive data. Our study consists of two parts. In part 1 of our study, we first recruited 80 Google Assistant users through the crowdsourcing platform Prolific. These users were first asked to take a generic survey where we tested their background knowledge about Google Assistant, as well as their initial thoughts about data collection and access. We also collected demographic information in this survey. After completing the survey, we asked users to share their Google Assistant data with us. In order to do so in a responsible manner, we developed a browser extension which we asked users to install after completing survey 1. This extension redirected users to Google Takeout, which is a service provided by Google to download all collected data collected across all its products and services. Since we were interested in only Google Assistant data, the extension automatically unchecked all other data fields selected by default and then created an export of user Google Assistant data to their personal Google Drive. The users were then asked to share the link to this Google Drive file with us. Now that you all are aware about the different types of data Google Assistant might collect, this approach can seem a bit invasive. In order to make sure our data collection was as privacy preserving as possible, we took the following measures. First, all users were presented with a detailed consent form that explicitly mentioned each part of the study, as well as the nature of data collected. Only users who voluntarily agreed to participate were allowed to proceed with the study. Second, a study protocol was approved by the Institute IRB. Next, each user was represented by the unique Prolific ID and not linked to any personal information. Fourth, through a Google Drive link sharing approach, we provided users with the option to withdraw access anytime they felt uncomfortable with any of the study procedures. Next, we made sure that no researcher ever manually checked the user data, as our entire data processing pipeline was completely automated. Finally, we do not involve any third-party services in this data collection process. This Google Takeout data comprised of two main elements: the MP3 audio recordings for users' interaction with the assistant, and an HTML log file which linked these MP3 recordings with transcripts and other metadata. We developed a series of binary classifiers based on potentially privacy-violating scenarios identified from previous work, such as the presence of a lot of noise in audio recording or presence of regret words, etc. For each user, we passed their data through this binary classify pipeline and finally sampled one file from each of the 12 categories. Then we embedded these in a programmatically generated survey that we hosted on our department servers. This brings us to part 2 of our study, where we invited participants to take this personalized survey after we had processed their data. This survey comprised of questions about their own data, such as asking users to label sensitivity of specific presented data elements in terms of whether they would like Google to collect similar data elements in the future. Additionally, we also included some general privacy perception related questions. Now moving on to the results. Our participant pool had a male gender bias, with 69% male participants. In terms of age, the participants were roughly evenly distributed, and 30% participants reported an association with computer science through studies or job. In terms of Android usage, our participants were long-time Android users. In terms of Google Assistant usage, most of the participants were long-time Google Assistant users, with 73.8% using it more than a couple of times per week. In terms of actual data collected, we found that our median participant had a massive 354 audio recordings and a total of 837 data elements, which included audio, transcripts, and location data. Now moving on to user perceptions of data collection. We found that most users were aware that Google Assistant collects some data, but more than 30% users were not aware about the collection of potentially sensitive data types, namely audio, transcripts, and location data. Moreover, we found that users felt more uncomfortable sharing these data elements which they were less aware about being collected. Overall, participants wanted to restrict access for 17.7% of collected data. We also looked into social space theory and correlated it with access control preferences for this data. We provide many more results in the paper. We also asked users some questions to understand the effectiveness of My Activity dashboard. Worryingly, 40% users had never heard about this tool. Also, we found long-term users to require more assistance with the dashboard, confirming the cognitive overload issue that was presented earlier. Overall, users expressed a need for assistance in finding sensitive data elements in the dashboard. This brings us to the final section of today's talk, where we explored the use of machine learning to help users automatically find the sensitive data. We envision a human-in-the-loop based design where the dashboard essentially provides some sensitive data recommendations to the users and then learns adaptively based on user decisions. We formulated this problem of automated sensitive content recommendation as a machine learning binary classification task, where we aim to train a system that can predict if a particular data element is sensitive or not. The output for such a system can be a list of data elements ordered by decreasing sensitivity. As ground truth for the training task, we use the labels assigned by users to their personal data elements presented in Survey 2. We explored several supervised learning algorithms such as XGBoost, random forest, logistic regression, etc. to train our machine learning system. We extracted several features from these data elements for prediction. These can be placed under 3 categories: user-based features such as age, gender, audio-based features such as tempo, spectral contrast, and text-based features such as the presence of emotion and regret words. As baselines, we used a random baseline which randomly predicted a data element as sensitive or not, and a baseline based on feature vectors generated using the 12 binary classifiers we used to get personalized elements in Survey 2. So can we use machine learning to accurately predict potentially sensitive data elements? Our results showed that the XGBoost model performed the best with a 95% F1 score, achieving 76% or more improvement over all baselines. Therefore, the answer to this question is definitely a big yes. Again, we provide many more details in the paper, including the important features for prediction. To conclude, Google Voice Assistant is extremely popular, but also collects a variety of user data. Our study showed that GVA users wanted to restrict access to nearly 18% of collected data. To help users resolve this issue of manually inspecting thousands of data elements, we proposed a machine learning-based recommendation system, which achieved a 95% F1 score. For interested readers, we also have an extended version of this paper with appendices and many more detailed explanations. If you are curious about our research and want to reach out to us, you may do so using these email addresses. I thank you for your time and attention, and we look forward to your questions. Thank you.